Okay, so I'm going to show you just what happens if I add another one on here. What would you like me to add on? Just pick something. Exponential.
Let's add maybe
I times
2.
2. Well, I need a variable too. So 2x maybe?
2x.
Okay. So now I'm looking at a function e to the ix plus e to the I times 2x.
Ooh.
And instead of stopping at 2 pi, I think I'll go to like 20, just to make sure I go all the way around.
Yep.
Look at that.
Cool.
It looks sort of reminds me of the Loopy-Loops.
Yeah,
it's very loopy.
That's what it reminded me of too. Anna Weltman's Loop-to-Loops.
Well, I think there's there you could possibly make like circles with perfect circles inside them with this function.
Oh, really? How would you think we might try to do that?
So it loops all the way around, and then you go up, and then in a perfect circle come down.
Huh.
You could try.
You could try. Well, would you like to try to modify this graph and see what happens?
Okay.
How would you like to modify it?
Well, maybe you could make it like 3.1. Maybe you could try like pi x.
Well,
Pi times x.
Pi times x? Okay.
3.14.
I'll do 3.14.
Whoa.
what?
How did it get so complicated? It was just that one loop-to-loop.
Yeah. It did get complicated. I think I should have checked. I'm a little rusty with Mathematica, but I think pi is just capital P-I.
Pi
And I probably need a times. Yeah.
doesn't really change.
And let's see, maybe if I go to 200 this time.
Whoa.
Whoa.
That's neat. Let's get that flower design in the middle.
Yeah, what do you think's going on here?
I don't
Why
know.
do you think this got so much more complicated when you put pi in instead of 2?
Well, maybe you're doing like more rotations now, because you're doing. Well, I mean, you're doing some more rotations.
Maybe I'll do 2,000 times around and see what happens.
Well, it's like chaotic right now.
I see. Maybe this will turn into a perfect edge. Maybe like a filled-in circle. If we go farther.
Interesting. Maybe I'll back up to 400 just to...
And then it just...
It sort of looks like it's drawn with a pencil now.
Yeah, it does. You're right. What do you think's going on? Why is it, why was 2 so simple and pi became so complicated?
Well,
Maybe
maybe
because pi's in like an infinite series. Well, not really a series, but
There's the first 2. They're just going from 0 to 200 again.
Maybe it's because like you're using decimals instead of...
yeah, because you're going like little ways around, like 0.1, 0.04, 0.001, and then you're going like all these little bits around.
Yeah. Now, if we approximated with 3.14,
It just becomes this.
Whoa.
I do 200. Now, what if I do 2,000?
It looks
But it gets-
basically the same.
Yeah, basically the
It's a little
same.
complicated still. Though it does seem to be different here a little
Yeah.
bit.
Yeah, it looks like clearer.
And it doesn't look like... It's... This design in the middle is smaller.
Because you're going less.
Okay, that's interesting. All right, how else could we change these? Let's go back to something that we can understand. That's a little easier to at least visualize. This one.
Well,
How else could we modify this to make some other pictures?
we could make...
Maybe if we
different-
make it symmetrical, if we had a fourth variable, would it create a kink on the other side?
What do you mean a fourth variable?
Like we have 3 up here, or wait, I thought we had a second one there.
I don't know what you mean. Huh?
Like I thought we used to have 3 up there. Like there was another imaginary one, or
Okay.
maybe I'm just remembering things wrong.
All right. So how many do we have?
We have 2 up there now.
Okay.
And if we add a third one, we could create a kink on the other side.
All right. Let's add a third one.
Okay.